Have you ever really stopped to think about where you come from? I mean, really come from. Not just your parents or your ancestors, but the actual stuff you're made of? Well, the story is way bigger, way older, and a whole lot more explosive than you probably imagine. Today, we are going on an incredible journey, 13.8 billion years into the past, to uncover the cosmic story of evolution, starting from the very first moment of everything. And this, right here, is the heart of it. You see, to truly understand our own existence, we can't just look down at fossils in the dirt. We have to look up, at the stars, because that's where the story of every single atom inside of us actually begins. So, let's rewind the clock. And I mean all the way back. Not to the beginning of life, but to the beginning of time and space itself. We're going to see how the stage was set for everything that would ever come after. You know, when we say the word evolution, our minds usually jump to biology, right? Darwin, dinosaurs, that sort of thing. But that's really just the final chapter in a much, much grander saga, cosmic evolution. This is the whole shebang, the complete story of how everything, from the biggest galaxies down to you and me, came to be. Think of this as our roadmap. What's really striking when you look at it this way is just how late we are to the party. Our planet, and especially life, don't show up until the very end of this timeline. A huge amount of cosmic history had to play out first, just to make our existence even a remote possibility. Okay, let's clear up a huge misconception right off the bat. The Big Bang wasn't some kind of bomb going off in space. No, it was the beginning of space. It was the moment space itself began to expand outward from a single, infinitely dense point, carrying all the matter and energy in the universe along with it. So, how in the world can we be so sure this happened? Well, we have two incredible pieces of evidence. The first is something called the cosmic microwave background. Think of it like the faint leftover heat, a kind of afterglow from that initial creation event that we can still detect everywhere in the sky. And second, there's the redshift of galaxies. We can see that light from distant galaxies is literally being stretched out, which is slam dunk proof that they're moving away from us. The universe is still expanding today. By measuring that expansion and studying that afterglow, scientists have been able to calculate the age of our universe with incredible precision. And the number they landed on? A mind-boggling 13.8 billion years. That's the timescale we are dealing with here. And you know what? Back then, the universe was, well, it was kind of boring, chemically speaking at least. There was no carbon, no oxygen, no iron, none of the ingredients you need to build planets or people. It was pretty much just the two simplest, lightest elements, hydrogen and helium. It was a universe completely incapable of creating life as we know it. So, that raises a pretty big question, doesn't it? If the universe started out with only these simple elements, where did all the other stuff come from? Let's dive into the next phase and find out how the universe got a whole lot more interesting. The answer, it turns out, was lighting up the darkness, the stars. They aren't just pretty little lights in the night sky, they are the universe's element factories. Inside their cores, the temperature and pressure from gravity are so immense that they literally smash atoms together, forging new, heavier elements in a process called nuclear fusion. And this whole thing happens in stages. For most of its life, a star like our sun just fuses hydrogen into helium. But as stars get older and bigger, they can start fusing helium into carbon and oxygen. Sound familiar? The absolute biggest, most massive stars can keep this cosmic assembly line going until they've built up a core of iron. But here's the catch. Fusion in a star hits a wall. A big one. It stops at iron. Trying to fuse anything heavier than iron actually takes more energy than it creates. So that leaves a huge mystery. Where did all the other, heavier stuff come from? Like gold or silver or uranium? The answer comes from one of the most violent and breathtaking events in the entire cosmos, a supernova explosion. When one of those massive stars finally runs out of fuel, gravity wins the epic tug-of-war. The core collapses in on itself, triggering an explosion so powerful it can briefly outshine its entire galaxy. And in that single, violent moment, the pressures are so extreme that they forge all those elements heavier than iron, and then they blast them out into space. And this is the most beautiful part of the whole process. These cataclysmic explosions aren't just about destruction. They're profoundly creative. You can think of them like cosmic gardeners, seeding the universe with the heavy, complex elements needed to build the next generation of stars, rocky planets, and eventually, life.
All right, so the universe is now seeded with all of our ingredients, scattered far and wide by dying stars. So how do we get from that cloud of cosmic dust to our home?
Well, about 4.6 billion years ago, a huge cloud of this enriched gas and dust started to collapse under its own gravity. Most of it fell to the center and ignited to become our sun. The leftovers flattened out into a spinning disk, and in that disk, little bits of dust and rock started bumping into each other, sticking together and growing bigger and bigger over millions of years, until they became the planets, including our Earth. And our newly formed planet, it turns out, had the absolute perfect recipe. It had all those essential elements forged in stars. It had liquid water, the perfect solvent to mix them all together. It had energy from lightning, volcanoes, and the sun to power chemical reactions, and critically, it had a stable environment with an atmosphere and a magnetic field to protect it all. The stage was finally set. This brings us to the final, and I think the most profound part of our story. We've traced the line from the Big Bang to the birth of Earth. Now let's connect it all directly back to you. You see, it's all one continuous story. Cosmic evolution set the fundamental rules of the game. Then, stellar evolution created the actual building blocks. Planetary evolution built the workshop, our Earth. And only then, after billions of years, could biological evolution finally get to work, taking those raw materials and assembling them into life. So here's the takeaway. You aren't just living in the universe, you are of the universe. The very carbon in your DNA, the oxygen filling your lungs as you breathe right now, the iron in your blood, every single one of those atoms was forged in the heart of a massive star that lived and died long before our sun was even born. You are quite literally made of stardust. And so, we'll leave you with this final thought to carry with you. If we really are all made from the ashes of stars, if we have this deep physical connection to the cosmos, what does that say about our place in this universe? What does it mean to be the universe experiencing itself?